part 2, I want to examine these two pieces a little bit more closely. And I want to make sure you understand how they fit into the overall mechanism. The base has several posts, and that's being generous to call them posts, sticking up, in which the motor fits in. I know this is the right position. The axis that's going to turn the clock is off center. You might expect it to be in the center, but it actually fits up into this piece here. So this fits over, and it fits together. It turns, and then this turns. The other piece we're going to examine is the switch. I know the switch goes in with the push-pull up here. There are two larger posts that will go into this. There we go. And it fits in here. The rest of the piece, for example, this and this fit in, as we described before, how this is the timer on. The piece down here, which we'll look at in a second, is pushed in. Now, with the timer on, it goes by the gray flanges that push in and out. But what we're going to look at is the inner parts of these. And what I'm going to take apart is this switch. As previously mentioned, it has a piece that has been cut off here. It has power in and electricity out on this side. And this controls whether it goes in or out. Now, what is the mechanism that I'm going to uncover inside here? I would like you to take a few minutes while I pry this apart and imagine what it is. In a second, when I just about have it open, I will ask you if you figured it out. But I found the seam that goes along here, and I'm going to simply insert my very narrow finger in here, and you'll see I'm slowly pulling it apart. It's not glued. It's the same type of post that held it together. There. So before I take off this one last piece, I want you to imagine, take out a piece of paper, draw a box, and link up this action. Turn it this way as it is in the switch. I push this in with connecting these two pieces in a continuous circuit. So let's take this apart. If you haven't attempted to draw a picture, draw it now. Turn the video off. Come back when you think you have an idea. And I will finish taking this apart. Now when I take it apart, I've got to be careful not to spill any of the insides out. And there is the mechanism. Push this down, and you'll see this silver piece right here. This is it's going to conduct electricity from either here or here down this way. And I can see two springs in here. And when I push it this way, I will make contact with the outgoing path. When it is in this position, it is open for this one. and it is in this position. It is closed, electricity is flowing through, and the timer will either be pushed over so it's continually on, this is upside down, and the switch is over on this side, continually on. Over in this position, it is off. But when the timer directs it, we'll push it that way. So this mechanism has a couple springs in here to center this piece. One spring pushes it back, pushes this out. The other one responds by keeping it in line. There is a small gap right here. When this is charged, has a contact to the outlet, then when I push it this way, the electricity closes and I have a complete circuit through here. All right, let's put this aside. You can compare this to your imagination. Basically, you have a way of moving it back and forth. When it is one way, it is closed. When it is the other way, it's opened. This provides the closure. This piece is the motor. Now, if you look at this end very carefully, you'll see there's a little bit of space in between this piece and this housing. Likewise, there's a little bit of space here. What I suspect is happening is that there's a piece of plastic that runs along the edge here, down here, and it catches on this. This is kind of like a door latch right here. So I'm going to pry this open with my finger, there. And likewise, I'll pry that loose piece open on this end. Now there's lots of pieces in here, and I don't know how they're assembled, but I'm going to very carefully take this off. Here is the motor. We're going to have to go into how this coil takes electricity, goes around, and forces this to turn. That's going to be another film. We're going to see that same principle, converting electric current through into a spinning motion in a motor, and we'll look at a series of motors. The other part I want to look at, which we've pointed out in others, is the gears in here. If you look on end, you can, well, I guess we're going to take them out. We can see 1, 2, 3, 4, 5, 6, 7 gears on these spindles. Now, I'm going to look for a defective one. Maybe it has a tooth missing. I don't see it, but sometimes what happens is these plastic pieces have a tooth missing, and it stops. It makes a sound as it goes around and around and around. My wife was complaining that the motor was making a sound. It was on continuously. That tells me it's someplace in the motor assembly. It wasn't just on when the switch was closed or open. So I'm going to assume that it is some type of motor, some defect rather in the gears. I don't see a defect at this time, but since plastic is one of the weakest part of the construction, I would suspect that. But from this one through these various gears, and I want you to look very carefully on this one, there's gears inside and outside. This gives me a ratio that if this turns once around, this turns once around, but in the process, look at the difference in the number of gears that match up to the next gear down there. So, one of the enjoyable parts of taking something apart is seeing how the subcomponents, in this case the switch and the motor, are put back together. Could I have repaired it? I doubt it. It's also interesting to see how it was assembled so that I didn't glue it. I could take it apart, put the pieces in it, and maybe if, for instance, This is not using 60 cycles, which is American, but uses 50 cycles, which I believe is European. You would need a slightly different set of gears. You would just switch out one of the gears. Instead of a 60 to 1, it would be 50 to 1 turn over here.
We've taken it apart. We've got a path for the electricity. When it is in the on position, but what I do not see right now is a path that is only on when this switch is up. So the question is, how do I have another circuit that I don't see? Do I have a path? That's why I had to draw this out. Do I have a path through this diagram that I'm not aware of? I should be able to trace it through the fingers, my fingers, along the path when this is closed, as it is now. So I'd like you to think about it. I'm going to have to think about it for a while to figure out what completes this circuit when the switch is off, in the off position. How are we going to do that? I'm Dr. B. This is STEM Sherpa channel, and we try to encourage rational thought where you go from a flow like we did with the electricity from point A all the way to point X. In this case, it has to go around and around. That's how electricity goes to make a complete circuit. Thank you for watching.